Hi students, we have come up with another interesting detailed video of physics. Here we are going to talk about electric forces. Now these two statements are very much familiar to you. Like charges repel and unlike charges attract. Okay, so this is very common, this we know from earlier classes as well. But how much repulsion is there or how much attraction is there is not available from these two statements. So the quantification of electric forces were given by Coulomb and we call it now Coulomb's law. Okay, so we are going to study today Coulomb's law. So like charges repel, unlike charges attract, but how much they attract or how much they repel can be known with the help of Coulomb's law. So we can write Coulomb's law gives us quantification of electric forces. Okay, quantification of electric forces. So let's see what it is. Coulomb's law. Okay, you know, Coulomb was a scientist who discovered this principle, and after his name we put it Coulomb's law. Coulomb found that if you have 2-point charges, suppose number one is Q1 and another point charge is Q2, and they are separated by some distance, suppose R. If there are 2-point charges Q1 and Q2 separated by some distance R, then the force acting between them is, say, F, is directly proportional to both the charges. That is, F is directly proportional to Q1 as well as Q2, and inversely proportional to, when I write inversely, I would write 1 upon, inversely proportional to square of the distance between them, that is 1 upon R square. So F is directly proportional to Q1 as well as Q2 and inversely proportional to the square of the distance between them. Okay, so we can sum up this as F is directly proportional to Q1 Q2 upon R square. Okay, and this proportionality sign can be removed and hence we have to put a constant. We call it proportionality constant. We'll put it as K. So K Q1 Q2 upon R square. Okay, K Q1 Q2 upon R square, where K is called proportionality constant and it has got a value 9 into 10 to the 9 Newton meter square per Coulomb square in vacuum. Okay, so the value is 9 into 10 to the 9 Newton meter square per Coulomb square in vacuum. Okay, so the force depends on Q1, the first point charge, Q2, the second point charge, and inversely with the square of the distance. So if you double any of the charges, the force becomes doubled, keeping other things constant. Okay, later on it came to know that this force is also dependent on medium. To account such variation, K began to be put in different manner. Okay, let's see how they tried to account for the variation due to medium. So they start putting K as 1 upon 4 pi epsilon naught, where epsilon naught is called electric permittivity of vacuum, and it has got a specific value. The value is 8.85 into 10 to the minus 12 Newton inverse meter double inverse Coulomb square. Newton inverse meter double inverse Coulomb square. Okay. Now, as the medium is changed, your epsilon naught has a different value. So for any other medium, we write K as, for any medium, for a given medium, we write K as 1 upon 4 pi epsilon, where epsilon stands for electric permittivity of the given medium, and this epsilon is related to epsilon naught as well. So this epsilon is equal to epsilon naught into epsilon r. And what is this epsilon r? This epsilon r is called relative permittivity. This epsilon r is called relative permittivity. It has got a different value for each and every medium. Generally, epsilon r's value is either 1 or greater than 1. So epsilon r is 1 or more than 1 always. 1 for vacuum and more than 1 for any other medium. So for any given medium, Coulomb's law can be written as F is equal to 1 upon 4 pi epsilon Q1 Q2 upon R square, or you can write it as 1 upon 4 pi epsilon naught epsilon R Q1 Q2 upon R square. Okay, Coulomb's law is medium dependent. Okay, and please remember this thing, that this is called F medium. Now F vacuum is 1 upon 4 pi epsilon naught Q1 Q2 upon R square. Okay, so when you divide 1 and 2, you will find that F medium is equal to F vacuum divided by epsilon R. Now this is a very important result. Suppose you have been given this epsilon R, which is also known as dielectric constant. It is also known as dielectric constant. Suppose you have been given dielectric constant of a medium, and you have been told that the force between a particular pair of charges with a particular distance between them is this much in vacuum. Then you can easily find out F medium using this formula. F medium is equal to F vacuum upon epsilon R. Now this is only the magnitude part of the Coulomb's force. There is another part that is called direction part of the Coulomb's force, which we will delve into another video. Hope this video will explain you many facts related to Coulomb's force. Please let me know if you haven't understood in comment section. Thank you very much.